How's it going, code fans? This is the Code Whisperer here. Today we're going to do something I'm excited for, which is make a sweet version of Snakes and Ladders in the browser. Now, if you don't know what Snakes and Ladders is, that's no problem because I'm going to do one of my favorite things, which is to watch commercials from the 1980s.
Here's a game about climbing up and sliding down. It's called Chutes and Ladders. You can land on something good, like rescuing a kitten in a tree.
Ah, you're going up, up, up the ladder.
Or land on Break the Cookie Jar. First one to climb to 100 wins. Chutes and Ladders really has its ups and downs, but mostly it's lots of fun. Chutes and Ladders is a Milton Bradley game.
All right, well, thank you, Milton Bradley. Now, we are making Snakes and Ladders, which is the non-copyrighted version of Chutes and Ladders. Personally, I prefer snakes. I'm born in the year of the snake, and I like Solid Snake. But enough about me. Let's get to it. So the game basically plays out on a big grid with snakes and ladders on the various spots. So we can start it out anywhere, but just to get our bearings, let's start by making the dice roll mechanism. That's kind of the simplest thing. So we'll make a button, and it will say roll dice. And we'll say on click equals roll dice. And so we'll make window.rollDice equal. So first we'll get the dice roll value. Should we use a library or just write something ourselves? Well, it's only take a second, so this time it's okay to write something ourselves. I'll kind of hide this, kind of rearrange these here so I got more space to work with. And I'll say const max equals 6, const roll equals math.random, times our max, which will give us a number between 0 and 6, and then we'll say math.ceiling. And then we'll just log what we rolled. Open up our console, and now if we click roll dice, math.cl is not a function. Right, math.ceil with the E before the I, because English is cool and makes sense. All right, so as you can see here in the corner, here you can see that we can roll a number from 1 to 6. So we've got our dice roll, that's a good place to start, but it's a little bit easy, if I might say so. So let's do something a little more robust, and let's make the board. And the board will kind of be, we'll have this JavaScript object representing the board, and then we'll kind of draw it with HTML and HTML tags. So we'll make a div here, and we'll make the ID equal to board. So how should we do this? Should we use two arrays like we did last time for our Othello game? I don't really see why not. It seemed to work. So let's represent the board as an array of arrays, a two-dimensional array. Say const board equals blank. And now let's define some values for the size. Width equals 8. Const height equals 8. So that's not too bad. Now let's loop through our width for var I equals 0. I is less than width. I plus plus, so we'll have a for loop here. And we'll say let row equals board equal a array. And then we'll push the new array to the board. And then we'll copy this for loop and do another for loop. And and we'll make this, actually we'll make this top one x's and this lower one y's. We learned our lesson in the Othello game that I and j, if you're doing something that's x's and then y's, just make the variables x and y, and it'll be a lot easier for you to do. And then so for each of these board elements, for each of these array, for the number of height, we will push an object with width and height. Now, did I get my x's and my y's right? So I know this is nitpicky, but actually it should be y's, because first we're counting the first element of the array represents down. And the second one should be x, because now we're going across. And this should be width here and height on the top. Good work, CodeCat. Everybody say hi to CodeCat. Oh, is she in the shot there? Good work, CodeCat. I hope we got her in the shot. She just loves writing code with me. CodeCat, CodeCat. So for each of this row, for each of this value, we're just going to push to the row a new object, and we'll just give it an x and a y, and then an occupied is null. And we'll log our board. Did it work? So here in our console, oh, that's busy. Nice, that's looking better. You can see we got 8 arrays of 8s, and they're all counting. They all have their x and y values set. Good work, CodeCat. Now let's render the board. Let's create a new function called renderBoard. Const renderBoard equals an arrow function. And now we want to loop through the board and then draw all its elements into the web page. So we'll define an empty string as the HTML. Let board HTML equal boom. Empty string. Now we'll do a board.forEach, and so each one will be a row. And now we'll do a for each in the row. And that's our column. Or no, that's our square. So we'll say for each square, we'll just add a little square to the board.html. Board HTML dot inner HTML equals, or plus equals, because we're adding a new part to it, and we'll just make a div to represent our square. Div class equals square, and close the div. And now we want to give it some properties. So we'll say style equals, and how are you supposed to do styles again? That's always tricky. Let's open this up a little so we can see what we're typing. Square style equals, make a little pair of quotes, and now I think it's got to be, there's no surrounding curly brackets, but it should be something along the lines of top square dot y times, and we'll just define a constant for our board size. Board size const equals 50. So that should at least give us a board of things. Now let's call render board in our thing. And finally, after our for each loop, we'll say document.get element by ID, and we'll get the board, and then we'll set the inner HTML to board HTML. And this shouldn't actually be board HTML.inner HTML, it should just be board HTML. So we're kind of storing it up in there. And let's add a console here to make sure it's doing our thing. So we're seeing here that it's rendering our board, and we're seeing nothing. I reckon that's because we don't have any classes for our CSSs. So let's make a class for square, and we'll say position absolute, width is 50 pix, height is 50 pix, background color is sandy brown, blah. So there it is, but that's not really what I was expecting. I was expecting a nice kind of, it to be a bit taller, you know? I was expecting it to be a little taller. What is going on here? So according to our console inspector, are our styles being noted? So yeah, it does catch our top, but does it have to be pixels? Yes. Let's just try adding pixels to this code and see if we get a nice cascade. That's good. I like it. Let's make some styles for our board. Make the position absolute. Top 50 pix, left 50 pix. Not bad. So now we kind of have our board going there. And now let's update our HTML so each square also has an X. Semicolon. It's a little bit of template string there. Left square.x times board size const. Pixels. Great, so here's our board. And let's give each of these squares just a little border so we can see where one ends and one begins. Nothing fancy. I feel that every square should have something that separates it from other squares, you know, keeps it safe. So that's some pretty good stuff. So I just realized that in a real game of snakes and ladders, you kind of go in this pattern back and forth. But that's going to be complicated to implement, so we're just going to fudge it a little bit and go like this to play our game of forks and ladders, or even from the top. We'll work out those details later. Maybe it'll be reverse snakes and ladders, where you start at the top and descend your way down to hell. A Dante's Inferno version of snakes and ladders, if you will. So our roll dice button is set. We're rolling the dice. Now we need to have pieces. Let's just start with one piece. So we'll make an array for players. And it'll be an array. And the first one will be an object. And the name will be Cloud. And the ID will also be Cloud. Or I guess we'll just use the name for this one. But in a real production one, you want to have an ID in case two users pick the same name. Our code would break. Mysteriously. And we'll say let current player turn equals 0, which means it's the first player in the player's index whose turn it is. Now let's handle our roll dice. Also, we'll give the players a position. Position equals 0. This indicates that it's in the first square of the snakes and ladders. And now here, when we're actually making our board, we're actually going to create an incremental position counter for each of our squares. So each square has its unique position number that's one greater than the square before it. So here we'll say row put position, and then after we do each position, we'll increment it once. So each one has its own unique position. Now, when we roll this dice, we'll get the current player. Let current player equals players current player turn. And then we'll say the current player's position plus equals the roll. And then we'll call render, what's our render function called? Render board, which will render our board and we'll update it to also render our players. So far, so good. And we'll just console log our current player here, so things are still all good. Oops, that's just invoking it like a function. That's going to just fail. Console.log current player. So if we roll the dice, great. So you can see that as we click it, Cloud's position is moving ahead in the board. Pretty fudging cool, if I do say so. So how are we going to do this? We want to basically draw a piece inside each square. So how are we going to do that? I guess as we're drawing the board, after we draw the board, we'll draw a loop through the players for each player. And so we'll actually, all we care about is the position, so we'll just use an object destructurer to just get the player's position. Or no, we want their whole details. Let's get the whole player. So we want to find the x and y coordinates of whatever position they are. So we'll say let square equals null. Then we'll copy these for each loops and loop through our squares again. In a bigger project, we could have kind of some logic that we can use to kind of keep all the looping through our squares for one place, but in this one, it's fine. So we'll say if square dot position is equal to player dot position, we'll just log player is on this square. Square. So it's clear that. Make sure it's just calling once. So we're not seeing the player is on this square message, but it always should be. Let's just put a log here for each of these and see what it's comparing. Console.log compare square and player. All right, so what's cooking now? Are we seeing all our compares every time? Right, so the squares, there's a problem with our square positioning. They are not counting after 12. What's the problem here? Right, every time we start our loop, our position increment is going back to 0. Let's put let position equals 0 outside of this top loop. And now every time we roll the dice, let's get rid of this comparing thing. It's going to crash our thingy since it logs so many times. Nice. So every time we roll, it knows what the X and Y position of the player should be. So now we can draw these players onto the board. So back here, up here, we define our players. I'm going to give cloud a color. And I guess gold should be appropriate, or yellow, but let's go with gold. Oh, this code is wide. Wide code. Don't want it too wide, don't want it too thin. So we'll draw a player onto the square. Let's expand our CSS window a little bit. And we'll make a class for player, and players will have a position of absolute, a height of 40 pixels, a width of 40 pixels, a border radius of 50%, making them round. And let's just give them a border for now so we can see it when we draw it. So now we'll append to the board HTML here inside our loop where we're matching the player's positions to the squared positions. Say board HTML plus equals, and we'll make a div class and call it player. And we'll give it a style. And we'll just copy the style from the square code, since it's quite similar. Everything from style to the end of the brackets. Need little template strings in here. Cool, and you can see it's drawn our little piece here. I very much like it. So let's make this +5. Is that what it takes to get in the middle? Yeah, we'll make each of these values here +5 so it shows up in the center. And we'll also define a background color of whatever the player's color is. Cool. Nice, looking good. Nice little board we have. And this board's pretty ugly, so let's fix that up. I'll put a new variable here, and I'll call it let black square equals false. Now when it's making the squares, each square will have a color, and we'll say the color is black square if it is the color's black, or else it's, I don't know, red. And then we'll toggle the black square variable. Black square equals not black square. And every time we draw the square, we'll give it a color. Background color is equal to square.color. And that's not equal, that's a little colon there. Nice, but that's not the pattern that I wanted because it doesn't really alternate. Can we cheat a little? I'm just going to make it 9 by 9 to get the nice pattern without doing any extra work. Ha! Coding's fun, isn't it? So now we have our piece, and every time we roll the dice, the piece moves ahead the appropriate number of pieces. This is already pretty cool, considering it only took us 20 minutes to make. And then once you finish, it just goes off. So we'll have to finish that, fix that up. But I guess it's time that we put in the most important element of chutes and ladders, which is a chute. But let's see, it doesn't make any sense if the player goes starting at the top and then chutes make them go up and stuff. Let's make them start at the bottom. So all we have to do here is change the way that we're drawing the board. Or rather, maybe if we just invert the positions, so the position starts at the last one and then works its way backwards, then the first position will be the last piece that was rendered. I just want these to be backwards. So we'll change this up. So we'll say y equals height, y is greater to or equal to 0, and y minus minus. So now we're backwardsing through our y, and it's just going to freeze a little bit there, but it caught our freezing, so that's nice. Oh no, we crashed the whole thing. That's tricky. And now the whole thing's crashed. Can I open it again? Right, okay, so here's how it was. I just opened it again. Still looks okay. Now, let's rewrite this quicker so it doesn't crash. Let's comment it out before changing it. So y equals height, y is greater to or equal than 0, y minus minus. Now let's uncopy that and hide that. Cool, so now it goes from the top to bottom. Like I said, it would be cool if it kind of reversed, like in a real game of Snakes and Ladders, but you know, that's simple enough to implement if we really wanted to. So let's define our first ladder. Everybody loves ladders, everyone hates chutes. Const ladders equals, and it's an array. And each ladder is an object in an array, and all it has is two values. Start, which is the position it starts in, 5, and end, the position it ends in, 22. Now we want to draw the ladder from the start to the end, and I have actually no idea how we are going to do that. JavaScript, draw a line. Works with Canvas. Could we do it with anything other than Canvas? Looks like this guy has a create line function, which is pretty nifty. Maybe we should draw a canvas on top of our board to draw the lines on it. I think that's probably going to be our best bet. So let's give that a shot. Why not? So we'll add an element here and call it our canvas. Well, I'll just call it canvas, actually. So let's just copy this code and see what happens, this canvas drawing code. And I still have this frozen window open. It's really frustrating me. Go away. All right. So we'll just copy this canvas code in and see if it does any good. And we'll just get an element of my ID called canvas. Ugh! Not again. I gotta rewrite this code again. Stupid Codepen. 1 second. Always save that work, people. All right, let's try copying it again. Maybe it won't crash. Cool, so we've got a little line up here, which looks promising. This should probably work for our purposes. So what are you going to do? We want to give this a width and a height, and sort of a thick quality to it. Canvas, line, stroke. What's going on here? So we set the dot line width. Dot line width is 15 pixels. That's not a method, actually. It's just equals, line width equals 15. And can we make line color? No, maybe if it's a appropriate string. Canvas, line, stroke, color. Stroke style. Sure, why not? Anything goes in the world of programming. Stroke style equals this. And I'll just add a style for our canvas because we want it to be absolute as well. Position absolute. Nice. And let's just copy these board positioning things for now. Cool. So it's drawing a little line relative to where we're going. Now, can we get it to draw a line from our start of our ladder to the end? That's going to be the real question here. Let's close this up and let's kind of convert this into a function. Function draw line color equals 333. Does it not like me having that default value there? Or maybe it needs a closing thingy. And then this one. Good. So this is drawing a line. Now what we're going to do is we're going to make this, put this in an object, because we're going to want to pass various things. And if we don't want to worry about the order of it, then we'll just pass an object with a color property. Looks pretty promising, actually. So here in our draw board, now we'll do a loop for ladders. And do we have our ladders array? Our ladders array must have been lost to the sands of time, like that. Ah! Stop crashing. Const ladders. Start 2 and 22. And save. Haha. Now we'll try here. We'll say ladders for each, and then for each ladder we'll draw a line, and we'll just make the color green because ladders are good. And we'll make the stroke size equal to the color. Now let's use the same algorithm we used above to figure out where it should start and end. We'll just loop through the board and loop through the squares. So if the square.position equals, but not player.position, but rather ladder.start. And we'll just hold these two variables in limbo. Let's start equal 0, or no. Let's start pause equal x0, y0. Start pause.x equals square.x times and board size const. And start pause.y equals square.y. And we'll make an and pause. So we'll define a start and an end. So here we'll draw a line and then we'll pass the start pause and the end pause to that. Our start pause is all set, so let's make sure it starts in the right place. We'll rename these variables for draw line, start pause and end pause. And here in the first move to, we'll make it start pause.x, start pause.y. So it seems to just be hiding off the screen now. Let's do a log here. Start pause, start pause. So that should all be good. Start pause.x, start pause.y. So where's our canvas line then? Our canvas is too small. Let's give the canvas a bigger size. Height doesn't even matter. Width really big. Codepen keeps crashing here. I'm wondering why. So why isn't this line showing up? So I can't imagine why we're not seeing a line that's sort of doing its thing. What if we make the line 2, 0, 0? Oh, cool. So there it is. So it's starting all the way down there. Guess we do have to log this start pose. Yeah, these consoles are definitely what's crashing it. We don't want to log the board every time. That's not helping our application. We don't want to log the start pause. So it's not, it's just going to this crazy place. I don't know where it is, but it's just so huge and it doesn't really make sense. Do we have to specify these as pixels? No, but the line 2 doesn't have pixels. We want this to be starting off at the square we described, square 2, not all the way down here. It's like it's using the whole canvas. What if we just make the canvas the exact right size? What if we change these properties to 500 and 500? So that seems to be okay. I guess these numbers don't define pixels, but kind of relative movements of the canvas. Nonetheless, this is looking pretty good. Let us just clean it up a little. So let's copy this line of code here and help us find the end pose. So we'll define our end pause by updating our start pause code. And now we'll use this line to end pause. So according to this, our start position and our end position are both looking good. But where's our line? That's weird. Let's replace this move to with a 0, 0. Can we see our line if it starts at 0? Yeah, so we can see it if it starts as 0. What if we update this end pause line? CSX line to 0, 0. Is it at least in one right position? That's weird. It looks the same either way. You know what? I don't think this line is being drawn right. Let's change the code so it's correct again. And give it a shot. Let's see. HTML canvas pixels. How to draw on an HTML canvas pixel by pixel. Canvas line to pixel. Draw line takes 4 arguments? No. Canvas is tricky. All right, let's get rid of these and go back to just default values. Move to 100, 100. Line to 200, 100. So we should see just a green line right in the middle of our screen. Looking good. What happens if we fiddle with the height of the canvas here? Yeah, it moves, it changes everything. If the canvas is 100 pixels by 100 pixels, then it's in this place that we thought it would be. So saying pixels doesn't work. canvas is about the right size and about the right position. So we know the canvas's size, and we know that the numbers want to be relative to 100. So we can say const size ratio equals 500 equals 100 divided by 500, because we have our canvas set to 500. So we'll start with 0, 0, and then we'll make a line 2, but we'll multiply it by our size ratio. Cool, so that does look like a line going from 0, 0 to 200, 100. Let's try putting in our proper values. So we'll multiply this by size ratio, and this by size ratio. We'll multiply it all by size ratio. That does not look like it's starting in position 2. Does not look like it's starting in position 2 at all. Why is it not making sense? Okay, let's try changing tack a little. Instead of drawing a line, we're just going to draw a circle in the start position and see where that lines up. All right. Canvas, draw circle. Too complicated. Canvas, draw square. Cool, so we can just call a rectangle there and then stroke. Let's give that a shot. Just copy whatever code we need from up here. So it's drawing a little rectangle. And it hardly seems to be 100 by 100. Let's make all of these numbers equal. So that's x, 0, y, 0, Just make this maybe 10 by 10. No, we kind of want it to be the same size as one of our squares, 50 by 50. What's that? What's that square? This is the craziest square I've ever seen. This isn't right. It's not a 50 by 50 square. All right, what if we make this canvas 100 by 100? And we'll make the stroke style white or gray so we can see it. This canvas is all stretched and weird. Maybe give it a fill. ctx.fill equals white. Canvas square fill. Sure, so we don't want rect, we want fill rect. Man, I can understand that. I'm a modern kind of person. So we want maybe fill color, fill style. Good. So finally, we're seeing our 50 by 50 square, and it's not the right shape at all. Unless half of it's being cut off. No, that's just how it is. It's just a messed up, tall, wrong shaped square. Canvas doesn't have any parent. Do I have to close the canvas tag? Is that at the part of this? All right. Canvas square, not square. Setting the size of the canvas using the style attribute will result in scaling issues. Right, so don't style your canvas with CSS. Don't you do it. Style it right here in the HTML. Thank you, JavaScript. So we'll give this a width and a height of 1,000 and 1,000. Promising. So now things actually look proper. Let's rewrite this so it uses our lines. I really messed it up when I changed it. Oh well, maybe it'll just work. Erase this new stuff. I lost this var ctx, bring this back up here. All right, good. Now it's going from 2. No, that's not 2. Right, but the canvas position is not right. Right, that is square 2. we are all set, but it's in the corner, so we want to make the start pause. We want to give them, I don't know, 25. Start pause dot x. Let's get rid of this time size ratio. We do not want this anymore. We will just arbitrarily give it a little bit of extra position so it looks like it's in the middle of the square it's trying to go to. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. All right, so we have a line. It took us like an hour, but that's looking good. I've had some rough patches here, but it's all looking okay now. Let's erase all this excess code, try and get this code base into order and save our work. Tricky Codepen. So when we land on the start of one of these ladders, we want our whatever player's turn it is to move to the end of that ladder. And if you'll excuse me just a second, I need more coffee. Coffee and code, you can't beat it. Okay, we can't stop now because we are so very close. So what we want to do now is when we roll the dice and we move the player's position, if the position is the same as any starting of the ladders, we want to do that. So we'll say ladders dot for each ladder if ladder dot start equals current player dot position console log you stepped on a ladder, and we'll make current player dot position equal ladder dot end. Simple enough for a simple game. And now let's update this roll dice const roll equals 2, so we get the roll we need to test our new feature. Hey, look at it go. We did it, guys. It went to the end of the ladder, which is basically the whole game. Now all we have to do is add a second piece and a whole bunch of chutes and a whole bunch of more ladders. Oh, that's a lot of work. Can't we just finish now? No, let's finish Ultra Snakes and Ladders. This is cool. So let's fix this again. We know it works. Now, let's define another player. This should actually be pretty straightforward because of how we wrote our code. We'll make another character and we'll call them Sephiroth, and their color will be white. And if they're on the same square, that's all right. That's something that you can fix in your own time. I don't really mind about that. So we'll say players. And now after you roll, it's going to change the current player turn. So we'll say current player turn plus plus, but if current player turn is greater than players dot length, go back to beginning, or equal or greater than current player turn equals 0. So now it should alternate between Cloud and Sephiroth. Oh, look at them go. They're just racing ahead to play some chutes and ladders. Good stuff. So that's our 2 players. Let's finish off by making the snakes. So we'll define an array of snakes. We'll have one start at 50 and end at 36. Or I guess we don't really need to write too much code because snakes and ladders are basically the same thing, but a ladder has a higher end and a snake has a higher start. So let's try just using one array for both. We'll make a start 50 and an end at 34. And the way we'll know how to color it is we'll see if the start is greater or less than the end. And so we'll say const is ladder equals ladder.end is greater than ladder.start. And we'll make this color, if the color is a ladder, great, make it green, otherwise make it red. And that's awesome. Look, it's working, but we can't see our red ladders over our things. So that's fine. Let's change this alternate color. What's a good color for a snakes and ladders board? Let's try pastel blue. That doesn't look like pastel blue. Steel blue. And silver. Cool board. Cool game. Holy freaking smokes, folks. We did it. So as you can see, our players are making their way through the board just fine. I'm actually really thrilled that we were able to take this so far. This is really exciting. So this is a great project. So let's finish it up by adding just some more ladders and a win condition. I guess let's do that first. So we'll say if the current player dot position is equal to, and we had a position incrementer that we're making called position. So let's say if it's equal to where the position incrementer left off, the highest position, we'll say console.log player has 1. But if it's greater than the maximum position, we'll bounce them back. So we'll make the difference const diff equals current player position minus position, and then we'll move them back that many. So we'll say current player position equals position minus diff. So that's our win condition. That's all looking good. And we'll make a bool so the game can't keep going after player has 1. Oh, wrong code. Var has 1 equals false. If you try to roll the dice after has 1, you return. And has 1 equals true when a player is in the last position. Incredible. This is looking good. All we need to do now is add some more ladders, which isn't code, it's just for fun. Now this is kind of the fun part because this is where you get to make the game your own. You can decide where you want ladders, where you want chutes. Let's just make a whole bunch of those in. Try not to leave any out. So we'll make another ladder that starts at 12 and ends at 44. A chute that starts at 61 and ends at 19. That's a mean one. I don't like where that one's starting. Let's make it start 18. No, not exactly. Maybe 10. That's good. Another one that starts near the end. Start 70 and 83. Yeah, they sort of like cutting off hereabouts. I don't really know why. Let's check our canvas. Ooh, okay, so our canvas is in the wrong position. Guess we don't want this 100 and 100. But that moves everything off. We had it so nicely. It's off. Position. It's got to line up just right. Top 50 picks. Left 50 picks. That's looking good actually, but now we have to get rid of these hacks that we put in on the position. So what do you want? So do those all want plus 25s now? Yes, that is looking right. And let's make just one more big old snake just in the middle, close to the end, just to mess people up. Start 78 and 4. Ooh, that's a mean looking ladder. You don't want to mess with that one. All right, folks, we did it. We implemented the entire game of snakes and ladders. You can have more people, you can have more ladders, you can basically do anything you want in this application. A little animation would be nice, so you could add that. It's not trivial because the way our game is kind of just a state. It lends itself well to being performant, but not well to having animation. So that could be a challenge for you. But that's that. That's Snakes and Ladders in the browser. You can do it. We did it. And thanks for watching. I'll see you next time.